All right, so after we have discussed the background paper for this replication, let's now look at actual replication in R. So I'm going to replicate table 1, where I show the effects of these interventions on total calorie consumption. Table 4, where I show the effects of these interventions on knowledge and perception of calorie consumption and calorie content. And then finally, figure 2, which shows the effect on choice probabilities of choosing a low-calorie sandwich. So again, to recap quickly, I'm going to replicate the findings from the paper Promoting Healthy Choices, Information versus Convenience by Mr. Medal, published in the American Economic Journal Applied Economics. And the study describes an experiment where patrons in a sandwich shop were given different menus to choose the sandwich from. All menus contained the same sandwiches. They just changed the order to make healthy sandwiches more convenient to order, or they added information about calories and daily recommended calorie intake. And the goal of the study was to estimate the effect of providing information versus just changing the convenience of ordering something that is healthier. So since the output does not fit on the slides, because each of these tables in the paper contain at least 3 regressions, they're way too big to fit nicely on these slides. I have chosen to just not include them here. So I included them into a separate document called review.pdf. And you can just look at exactly the same code that I run here, but I also included the regression output from the code there. Here I'm just going to show you the original table and then the code that I used to replicate this. You can also find the paper to actually reference like the tables that I'm talking about here directly. First, let's load the relevant libraries, and we're going to use tidyverse and Rio like always, and we're going to use Magritter to use the assignment pipe symbol. We're going to use Stargazer for the output, Broom to extract coefficients from the regression output, Glue to create a string variable that contains that combines text and regression output. We're going to use geplot to create the plot, Knitter for producing the document, ggthemes to get some nicer background for the plot, and then finally that one we actually don't use. I should have taken it out of the code. Let's first load the data, and here I take a look at the first 10 variables. The nice thing about this paper is that most of the variables are already created, so we don't have to spend a lot of time going over tedious variable construction, and we can jump right into running the regressions and presenting the output. So the first table presents the effects of these different interventions. So there are a few information interventions where different information was presented, and the convenience interventions where the ordering was changed so healthy options appear at the top on the total calorie consumption. So since all the relevant variables have already been created in the data set, we can jump right into the regressions. The main regression, so table 1, we regress the total calories that are consumed on these 4 different interventions. And then there are some control variables for demographics, and I cannot show all of them here because the space is limited, but there is also a control variable for being African American, and then there are some interaction terms between being in study 2 and being featured, having been presented a healthy menu. So we see that there's also 3 regressions. First, we have the regression for study 1 only, we have the regression for study 2, and then we have them combined. So we have to run 3 regressions in order to replicate table 1. This part is relatively straightforward. I'm just taking the data and filtering out all the observations that belong to study 2, and only take the ones where study 2 is equal to 0, which means that they were from study 1. And then I run the regression of total calorie on calorie info, calorie reference, healthy menu, unhealthy menu, female, age, and African American. where I only take the observations from the customers that participated in study 2. And also note that all of these calorie info, calorie reference are dummy variables, so they're all either 0 or 1. To get the regression for study 2, I do exactly the same. The only thing that is different is I filter by having study 2 equal to 1, which means that these observations actually participated in study 2. And then I change the data for the regression, but the regression specification is exactly the same. Finally, the pooled regression, where you take the two together, contains 2 additional variables for the interactions between study 2 and featured menu, or actually 3 additional variables. And you can see this here. We have an initial dummy for being in study 2, an additional dummy for being in study 2 and having seen a healthy menu, and one for being in study 2 and having seen an unhealthy menu. And also again, since we have a dummy for healthy menu and a dummy for unhealthy menu, this means that the reference group is the group that saw a mixed menu that was neither specifically unhealthy nor specifically healthy. Also, the table contains a note at the bottom that presents the coefficient of having seen a healthy menu without the interactions. So this is the same regression, kind of the same data that they use in the combined study, but they use the regression specification that they used for the first 2 regressions. And they don't show the entire regression, they just show the coefficient for having seen a healthy menu. So we have to run 1 additional regression, and then to recreate this, this footnote, we're just going to combine this text here with all these, with the coefficient and these statistics. So first I'm going to run this regression where I use the full data set and this shorter specification that does not feature an interaction between study 2 and healthy menu. And from this regression output, I then extract the coefficient for healthy menu. So you can see that this is, we have one intercept and then 1, 2, 3. So this will be the 4th coefficient. And I round it to the second, to 2 decimals. Then I also extract the standard error for the same coefficient and round it to 2 decimals. And then I calculate the t-statistic for this coefficient that we call b here by dividing the coefficient by the standard errors and rounding it to 2 points after the decimal. I extract the number of observations. We're using the knobs function from the regression output. And then finally, to get the p-value, I use the t-statistics that I calculated here. And then I use the cumulative distribution function that gives us the amount of mass that is smaller than the t-statistic from the standard normal distribution. But then, since we want to have the mass that is above this value, we take 1 minus this, and since we have a two-sided t-test, we multiply this value by 2, and we also round this to 2 digits after the decimal point. And then finally, we take all of these components together and combine them into one string using glue. So first we have the b equals the coefficient, then the t-value with the number of observations is equal to the t-statistic that we calculated here. And finally, the p-value is equal to the p-value that we calculated here manually. And you can see this, how this looks combined here, where I printed. And I've left out the text before. I'm going to write the text directly into the Stargazer function because it makes it easier to print this on 2 separate lines. Otherwise, the line will just be very long and will go out of the document. I then take the output from study 1, study 2, and the pooled regression, include this into Stargazer, and then in the nodes, I first write combined effect of the healthy menu across studies without interaction effects, and then afterwards, as a second node, I include this nodes that I created here. And then this gives me a table that looks very similar to the table from the paper. And I recommend that you look at the output from the review document and compare it to the table in the paper. So the next thing is the perception of caloric content, where they asked the participants after they made their choice of what they estimate is the daily recommended intake for a comparable person to themselves, and what they estimate is the caloric content of the sandwich they chose. The reason for this is that they want to see whether any differences across treatments was driven by people simply lacking the information about how much calories are in these sandwiches, or whether people just have a complete misperception of how much calorie that they actually need as a kind of healthy adult with a sedentary lifestyle. So table 4 presents the effects on knowledge and perception, and it has one regression specification, but with 5 different outcomes. And the 5 different outcomes are the estimated minus the actual recommended intake. So it's kind of what is the error in their estimate of how much calories they should consume. Then the absolute value of this error, the error in their estimate of the calorie content of the sandwich, and the absolute error of this. And then finally, whether or not they agree with the statement, I consider the calorie content when ordering. This was reported on a 1 to 7 scale. And here you can see a screenshot from the paper. These are the regression specification is always the same, and they have these 5 different outcome variables. So since we have 5 different outcome variables and the same regression, it is very nice example where we can just loop through all these outcome variables and just run the same regression 5 times. And that's what we're going to do. So in order to loop through all of these outcome variables, I first create a vector with the names of the dependent variables. So the first one is estimated versus recommended calorie. Then the absolute value of this, the estimated minus actual meal content, and the absolute value of this, and finally whether they consider calories when ordering a sandwich or not. I also remove all the outliers of people who estimated the calorie content of their sandwich by more than 1,700 calories, because these people obviously have no concept of what calories are. So the authors removed them from the study. And now I will show you how you can just loop through these 5 dependent variables using a for loop, and afterwards I will show you how to do exactly the same by using map. In order to use a for loop, we first have to kind of initialize an empty list that we're then going to fill out in each iteration. So I'm going to create this list called table 4 output list, and I initialize it as an empty list by using the command vector with the mode list, and say it should be of length 5, but it does not contain any data yet. And then I loop through values 1 to 5. In each iteration, I fill the ith element in this list with the output from this regression. And in this regression, I just choose as an output, as a dependent variable, the column from table 4 data that has the same name as this element from the list of dependent variables that we want to loop through, and regress this on these outcome variables here. So in each iteration, we're going to save the regression output for one of these 5 dependent variables. And then I just put this list directly into Stargazer, and Stargazer knows how to handle a list of regression outputs. Now we can do exactly the same using map. I use the function map here, and I give it as an input the list of dependent variables. And then I write an anonymous function that is simply the lm function which is exactly the same specification from here. And I just say that it should take as a dependent variable the current name of the iteration from the dependent variable. And you can see that I changed the input here to this .x, and .x is simply a placeholder that says in this anonymous function, use the element from the list of dependent variables instead of .x. And what this does then, it just selects the column that has the same name as the name of the dependent variable that we want to use, and then runs this regression here. And the nice thing about using map in this case is that we don't have to first specify an empty list that we're going to fill in each iteration, because map automatically just collects all the output from each iteration and returns it as a list. So we can just use map and save everything as a list, and then it's called table4 map output. And they can include this into Stargazer exactly the same way as include the list from the for loop. And if you look at the review document, you will see that these two tables from these two different approaches are exactly the same because they do exactly the same. Okay, now finally, let's replicate a figure, and I'm going to replicate figure 2, which shows the effect on choice probability on choosing a low-calorie sandwich. And here you can see the screenshot from the paper. And this figure shows us the average, the number of people who chose or the fraction of people who chose a low-calorie sandwich from each of these three treatments, with the healthy sandwich, the mixed, the healthy menu, the mixed menu, or the unhealthy menu, and it separates it by study 1 and study 2. So we need the relevant variables that we need of course, to know for each customer whether or not they chose a low-calorie or high-calorie sandwich, because this is going to be the y dimension here. We need to know the menu that the customer was presented. Was it a healthy, an unhealthy, or a neutral menu? We need to know, did the customer participate in study 1 or in study 2? So first, since all of the factor variables come as dummy variables, so they just have a 0, 1 variable for being in study 2, and they have a 0, 1 variable for having seen a healthy menu, so yes, no, or having seen an unhealthy menu as yes, no. But to use ggplot properly, we should have one factor variable that just takes on 3 different values for these 3 different menus, either mixed, healthy, or unhealthy. So we first need to recode menu, and I'm doing this by using mutate and creating a new variable menu and adding this to the AHA dataset. And menu is just, I'm using this vectorized if statement function case when. So if healthy menu is equal to 1, then this variable menu should be called healthy. If unhealthy menu is equal to 1, this variable should be called unhealthy. And if neither healthy menu is 0 nor unhealthy menu is 0, it should be mixed. And you cannot see mixed here, but that's what it says. And then I also create a second variable for study, where I basically just recode study 2 into saying that if study 2 is equal to 0, then study is 1. If study 2 is equal to 1, then study is 2. And I turn both of them into factor variables. Now, let's actually use a ggplot. So I first create a ggplot object where I give it the entire data set into the ggplot object. And then I add a aesthetics layer where I say the x dimension is the menu. Let's do this here, right? On the x dimension, we have different menus. The y dimension is whether or not the person chose a low-calorie sandwich. And since this is 0, 1, we will transform it into just taking the mean of each of those. I say that the color is study, so it should be split into, the bars should be split into 1 for study 1 and 1 for study 2. And then on top of this, I add a geometry layer, and the geometry layer here is the layer called stat summary that calculates, first of all, I specify the function of y is mean, and the geometry should be a bar. And what this does here, it says that since it takes stat summary calculates some statistic from the data we give it, we want to have the function mean applied to the y variable. So now instead of, for example, giving the frequency of how many people chose a low-calorie sandwich, it calculates the mean. And since the expression is either 0 or 1, this will be equivalent to just the fraction of people who chose a low-calorie sandwich. I also say that the position should be dodge, which means that the bars shouldn't overlap. They should be separated, and the color is black. It's just the border of the bars. Then, since we need to have error bars, I need to add a second layer, second geometry layer, and I choose again stat summary. And I had to look up myself how to do this. I didn't know this before. But I will apply a different function to the data here, which is called mean CL normal, which basically just calculates the mean and the standard errors. And then I want to have the geometry error bar, again, position dodge with color black, and the argument here is the multiply, and this means just since I multiply by 2, we get kind of 2 standard errors on top of ball, to give kind of the standard errors of like a 95% confidence interval. And then I also changed the Y label to have percentage of customers who ordered low-calorie sandwich. And finally, I make it look a little bit nicer by adding the theme Economist and adding the color filling from the Economist article. This is how it looks like. So now we can see that most importantly that by default, this stat summary would just report the frequency of how many people have a 1 here, or how many people appear in this in the healthy study 1 observation. But since I said the function y, it should take the mean, it transformed it into the fraction of people who chose a low-calorie sandwich here, and then it also overlays this with the error bar.